Okay, pod 2, give me something.
No. Only thing that sucks is
We're backwards. Number 5. Pod 5.
Keep trying things over and over again.
Keep trying. Don't give up. Okay? I like it. You're going to need that strategy for sure. Pod 4.
If there's no islands, you can just stay to the left the whole time. Like, okay, in a maze, if there's no islands in the maze, as in it's stuck, you can just hug the left wall, the right wall, and
I am with you. I wasn't, okay. I wasn't sure what you were referring to.
Works.
Okay, so you can stick to one side. That's what I'm going to paraphrase it to, because that can be something that will work for us on Monday. Okay, pod 3, anything to add to those? Do the easy stuff first. Pod 6.
They were talking about mazes, so.
You're good? Nothing else to add? Pod 1? No? Okay, those are all good strategies. I'm going to tell you right now, okay? There is not going to be like one specific way to do every single problem. There are going to be a lot of different ways to solve the problems that we do today, Monday, Tuesday, Wednesday, quiz on Thursday. Okay? I'll hand your gold sheets out at the end of the lesson so you can see what our plan is. Okay? Kind of forgot about these gold sheets here. I'll get them out so I don't forget. All right? We're going to talk about the different identities today. Monday and Tuesday, we're going to verify identities. Thursday, we'll have a quiz over it. Okay?
Are we like switching like cosine to sine or something?
Let me tell you what we're searching. Okay? We're going to talk about the fundamental identity. So when I say the fundamental trigonometric identities, you're going to think of 3 different groups of identities. Okay? These are identities that you need to remember. And fun fact, you already know some of them. Okay? We have identities called the reciprocal identities. Reciprocal. That means we can take sine theta and change it to what, Caleb? So 1 divided by cosecant theta. We could take cosine theta and change it to 1 over secant theta. And we can take tangent theta and write it as 1 over tangent theta. Those are all identities because what is on the right side is the exact same as what is on the left side. It just looks different. Okay? We could also write them in a different manner. And these are probably the ones that you'll see more often that you'll need to use. Cosecant is the same thing as 1 over sine theta. Secant is the same as 1 over cosine. And cotangent is the same as 1 over tangent. Okay. I will tell you, the first question on your quiz on Thursday is going to be, what are the reciprocal identities? You don't need to write down all 6 of them. I feel like if you know 3, you automatically know the other 3. So I would focus on these right here because they're going to be the most helpful to you. Okay? You will also use these right here. But if you're going to write down 3, I would write down these 3. Okay? If you write down all 6, not going to be disappointed. The next set of identities are called the quotient identities. Quotient. Quotient means what? Answer to a division problem. Have we ever divided trig functions? Kind of when? Ratio. Okay. What about to like get a trig function? What do we do to get tangent? In the unit circle, how did we find tangent? Sine over cosine. Which made cotangent cosine over sine. Those are your two quotient identities. And the second question of your quiz on Thursday. Okay. Our last set of identities, your third question on the quiz, are the Pythagorean identities. What do you think that has to do with? The Pythagorean theorem. Okay. You don't need to draw this, but I want to show you where this comes from. A decent circle, right? Okay, this is our unit circle. Let's say we have an angle here. What do we know about the radius? 1. We travel over x and up y, but x represents the cosine of the angle and y represents the sine of the angle. Okay? So using the Pythagorean theorem, side squared plus side squared equals hypotenuse squared. Write that down. This is the first Pythagorean identity. There's going to be 3 of them. Yeah.
So you like square this word sign and not like sine and theta?
Right, because I don't want it to look like that theta is squared. And so we put the square with the trig function, so you can tell the difference between when the trig function is squared versus when the theta is squared. Does that make sense?
Yeah.
Okay. Okay. Now, don't write this down. I want to develop the next one. Okay. Are we allowed to divide both sides by the same thing? Okay. So what would happen, and like I said, don't write this down. What would happen if I divided both sides by sine squared? Okay. What is sine squared divided by sine squared? 1. Plus, what did we say cosine over sine was? Cotangent. So cosine squared over sine squared would be cotangent squared. And what about 1 over sine? Cosecant. Write this down. 1 plus cotangent squared theta equals cosecant squared theta. That's your second Pythagorean identity. You can either memorize it or, well, it's going to be in your best interest to memorize it, because I don't know if you want to take the time every single time you need it to divide both sides by sine squared of that first one. Okay? To get our third one, we're going to divide both sides by cosine squared. Okay? What is What is sine squared divided by cosine squared going to be? Tangent squared. Plus cosine squared over cosine squared is 1. 1 divided by cosine squared would be secant squared. Okay. Here are your 3 Pythagorean identities. That will be the 3rd question on your quiz. You have to know these 3 groups of identities in order to be able to do what we get into on Monday, Tuesday. Okay? Today's kind of like a foundation builder for what we're going to do Monday and Tuesday. Monday, Tuesday's like the heavy hitter stuff. Okay? Today we just kind of gotta get our minds wrapped around what's going to happen.
So what are we doing?
We're getting into verifying identities, where I give you this trig expression equals this trig expression, and you have to show me that they are indeed equal. So, we are going to skip that. Okay. The first thing I want to show you is you're going to need to be able to factor trig expressions. Okay. It's going to feel a little awkward at first, which is why I want to practice it now before we get into Monday's material. Thoughts on factoring this one? What pattern is this following? Okay, this is a difference of squares. If it helps you, you can write it as like s squared minus 1. Oh, well that factors to s plus 1 times s minus 1. Okay, I can see that, right? So over here, this would be secant of x plus 1 times secant of x minus 1. Okay. My biggest advice to you for factoring would be if you need to change them into just letters instead of the full trig function name, sometimes it's easier to see. You also could get a trinomial that you need to factor. Like I said, if you need to look at it as 4t squared plus t minus 3 and factor it that way. Any suggestions on how this is going to factor? Oh, we know this has to be 3 and 1, right? 3 times 1 is 3. One's positive, one's negative. We'll get there.
4 tangents would go 3.
Like this.
And plus the 1.
This is positive, this is negative. So this gives us negative 3t. This would give us positive 4t. Add them together to get the 1t. So we would write this as 4 tangent x minus 3 times 4 tangent x plus 1. You all can factor. You showed me that in chapter 2. Okay? Now it's just putting some trig functions in there. Oh, thank you, thank you, thank you. I got to talking and writing. Sometimes that happens. Better? Was that your question over there? Okay. All right. Most of our work is going to come from simplifying an expression. Okay? Today we have to work on simplifying an expression so that on Monday we can work with proving identities to be true. Okay? I have 2 terms here. What do you notice about the 2 terms that we have? Okay, both of them have a sign of x in common, right? Sorry, I wanted to write something on here for you. Okay, both of them have a sign of x in common, so we can factor that out. We can factor this to sine of x times 1 minus cosine squared x. Okay, now here's something you're going to have to be able to do. Our identities might not always look verbatim as how we wrote them down. Point in case. Sine squared plus cosine squared equals 1. Okay, well that's not what this looks like. It looks like it could be a rearrangement, right? If you see a 1 and a cosine squared together, or a 1 and a sine squared together, we could have that Pythagorean identity but just mixed around, okay? We have the identity, and this is just off to the side, you don't need to write this down. We have this identity. Well, if I rearrange this, if I solve for sine squared, then we would have 1 minus cosine squared. Do you agree? So what we can do is we can take 1 minus cosine squared x and change it to what? Sine squared x. So what we have is sine cubed x. And that would be simplified. The quotient and the reciprocal identities will be verbatim how you need to use them. The Pythagorean identities you could have to rearrange because there's 3 terms in them in order to be able to use them. Next one. Any ideas? Okay, last example, we could factor something out. Is that the case here? Nope. So thoughts?
You can change cotangent to cosine.
Okay, we know that cotangent of x is the same thing as cosine of x over sine of x. Okay. Now, we're multiplying cosine x over sine of x to cosine of x, which there's like this indivisible 1, or invisible. There's an invisible 1 there, right? So what we have is sine of x plus cosine squared x over sine of x. Well, that doesn't really look that much more simple than what we started with. We probably need to keep going. Okay? Now I have 2 expressions that I need to add together. What needs to be true about 2 numbers that we add together? We need to have the same denominator. This guy has a denominator of sine of x, which means we need to make this term have a denominator of sine x. Okay? What does that do? Here we have sine squared x plus cosine squared x all over our common denominator of sine of x. Aha! What do you notice? Grace, what do you notice? Okay, sine squared plus cosine squared equals 1. So we can take this sine squared plus cosine squared and turn it into 1. simplify, what's 1 over sine of x? Pretty cool, right? Do you see why I made you do those word things last night? Still don't see why? All right, write this down. Okay, here's a strategy that we're going to talk about today, and I'm also going to talk to you about on Monday. But if we have something like 1 plus sine of x, 1 minus sine of x, 1 plus cosine of x, 1 minus cosine of x. One strategy that we can use is to multiply by what we call the conjugate. We've talked about conjugates in here, right? And we can't just multiply the denominator. We would have to multiply numerator and denominator by the same thing. Okay? Why is this helpful? Remember, when we multiply conjugates together, we get difference of squares. So our denominator becomes 1 minus sine squared x. Okay? Remember how I told you, like, the sine squared with a 1 could be helpful? Let's go to this identity that I have written on the board. 1 minus sine squared x. Rearrange that in your head. What would that be the same as? Cosine? Cosine squared. Okay. Now what we can do, because you're used to working with fractions, what can we do with this fraction? If we have 2 terms in the numerator, we can split it up, right? We can write this as 1 over cosine squared minus sine over cosine squared. Please be sure to include the angle every time. I know I'm not saying it. I'm trying to save some voice here. But make sure you're writing the x or the theta or whatever it is that they give you every time. Okay? 1 over cosine squared. What's that going to be the same as? What'd you say, remember? Secant squared x. Good. Ooh, now we have sine over cosine squared. Any thoughts there? We don't really have identity for sine over cosine squared. Nick? Okay, so we know that sine over cosine would be tangent. And that would leave an extra cosine in the denominator, right? So what we can write is that it's the same as tangent x secant x. Okay? Now, some of you may argue that this really isn't any more simple than what we started with. Okay? Well, we don't have like a weird denominator in our fraction. Okay? So, you know, I guess that might be something to argue. Some of you may not feel comfortable because you don't know when am I supposed to stop, like when do I have the answer. That will become a lot more clear on Monday. On Monday, I'm going to have an expression that equals an expression, and we have to get both sides to be the same. So it will become more clear on Monday when to stop, but for right now, we have to get the practice in of using our identities. Okay, we are going to do one more example of solving or simplifying an expression. And then I have an additional short example to go through. So this one and another one, and then we'll call it a day, just for you, Eli. I know the formatting looks a little weird, but I did want to leave some space in between. Why do you think I would save space in between those two? What are we going to have to do in order to add these two fractions together? We have to have the same denominator, right? Is there anything common about our two denominators? No, not at all. So this fraction is going to need to be multiplied by sine of x over sine of x. And this fraction is going to need to be multiplied by 1 plus cosine of x over 1 plus cosine of x. Okay. So what does that do? We have a denominator of 1 plus cosine of x times sine of x. Our numerator here would be sine squared x, plus our numerator here would be cosine x plus cosine squared x. At your pod, I would like you to discuss the numerator. Do you see anything in the numerator? Pod 1 sees that sine squared x plus cosine squared x is 1. Anyone else see that? Okay, we can take this guy and add it to this guy, and it's 1. Okay, now you start to get excited here, right? Lindsay, why would we start to get excited here?
Because you have the same thing on top of that.
Yeah, we can cancel these out, right? So we're left with 1 over sine of x. Do you think that's where I want you to stop? Okay. Grace Farson, where do we need to stop? Or where do we need to go? You bet. Adding those two crazy fractions got us to cosecant.
Where do anybody write the fractions over that and you just write cosecant?
Well, you don't know what crazy function you're dealing with, or like an equation that you're dealing with, right? A lot easier to work with cosecant for sure, which is why we have these things to simplify down. When you get into calculus, you're going to have to use some of these identities to rewrite an equation so it's easier to work with, or take the derivative of, or take the integral of. But we'll get there. Okay, I promise you will need these in calculus. Okay, this is the last type of problem that you're going to see in your homework. This is something that comes in handy in calculus, the second year of calculus. Okay, but it's good practice for us now while we are talking about the trig identities. Yep, x equals 2 times tangent theta. Formatting is not beautiful on this. Okay, so what we're going to do is we're going to take 4 But instead of x, they're having us substitute 2 tangent of theta in for x. Right? Okay, well, what happened? What is 2 tangent of theta, the quantity squared? Or tangent squared theta. Okay? Alright, so underneath that radical, do you see anything common? 4. We can't just say, oh cool, 2 plus 2 tangent theta. No, 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 no. You can't take the radical and break it up with an addition sign. We have to simplify it first. So we can write this as 4 times the quantity 1 plus tangent squared theta. Oh, 1 plus tangent squared theta. 1 plus tangent squared theta is secant squared theta. Look at this. Now we have radical 4 secant squared theta. Now we can take that square root. I know I say this a lot, but trig identities is one of my favorite things. Okay? I know some of you are like hesitant right now, feels uncomfortable. You'll get over it. This is way different than anything we've ever done. For some of you, you're not comfortable right now, and that's a good thing. That means you're learning. What do you need to do this weekend? You need to practice. Okay? Those underlined ones, there's only 3 evens. Back of the book is probably going to tell you, well, I don't know. They might give you an answer, or answers may vary. I can't remember what they do. Just remember, there's not always like one specific way to simplify these. There could be a couple different things that you do, one compared to another, but you need to practice. Okay?
So I figured it out. Winter to summer.
Okay, put it on the board for me. So I can